So in previous video, we done part A, B, and C. So now we're going to graph the piecewise defined function f of x. So I mentioned earlier, in order to graph f of x, we need to graph three individual functions. Okay, specifically, first we need to graph f of x equals negative 2x plus 1, where x is from negative 3 to positive 1. Okay, include negative 3, not include the positive 1. Second, we need to graph f of x equals 2 when x equals 1. This is a single point, right, which is 1, 2. And then third one, we need to graph f of x equals square function, and then x greater than 1. All right, so this part is a straight line for the first part, straight line, but it's not the whole line, it's a line segment. Second part is a single point, 1, 2. The third one is a parabola, but part of the parabola. Okay, so it's like, if I graph briefly, okay, it's like here is a 1, 1 parabola here, right? It's supposed to be, parabola supposed to be like that, right? If this is a point 1, 1, and then we don't want this part, we only want the right hand side part. Okay. All right, so let's just do the first one. First one is a straight line, and then we need to identify some points, right? So I'm going to create a data table. Here's a x, here's f of x equals negative 2x plus 1. So what points we needed to identify, okay? Because x is not all real numbers, it's only from negative 3 to 1. So this two boundary point is important. Okay, so we want to evaluate when x equals negative 3 and when x equals positive 1. And what other points x and y intercept is important. Actually, from the previous video we already got, right? When x equals 0, y equals 1. When x equals 1/2, y equal to 0, right? Those are the important points, so we need to include it in the graph. And then boundary point, let's evaluate it. When x equals negative 3, replace x by negative 3. So negative 2 times negative 3, that equals positive 6, right? Positive 6 plus 1, that's positive 7. And then when x equals a positive 1, replace x by positive 1. Negative 2 times positive 1, that's still negative 2, plus 1, that's negative 1. Okay, so we have 4 points on the line. Is more than enough to graph the line, right? All right, so let me see where I graph is better, bigger space. Okay, I'm gonna graph right here, okay? So first I need to set up rectangular coordinate system and then put a scale on. 1, 2, 3, 4, 5, 6. All right, and then negative 3, 7 is about here, right? Negative 3, 7. Negative 1, 1, negative 1. 1, negative 1 right here. And then 0, 1 is right here. 1/2, 0 is right here. Okay, so okay, my hand graph not accurate, okay? And then when x can equals -3, right? That's a solid point. But x cannot equals +1, so this point need to be deduct from this line segment. So I draw a shallow circle, okay? And then put the coordinates, that's 0, 1. Here is 1/2, 0. Here is 1, -1, okay? So this piece, this line segment is the graph for the first part of piecewise-defined function. All right, and the second one is a single point when x equals 1, y equals 2. This is a solid point. Okay, the third one, quadratic function. Okay, quadratic function, we need another table than x, f of x equals x squared. So we can get x only a positive number, right, greater than 1. So 1 squared is 1, 2 squared 4, 3 squared is 9. Okay, so we just got the 3 points. 1, 1 is right here, right? 2, 4 is here. 3, 9 is about here, okay? So it's about like that, okay? So it's supposed to be a parabola, right? So if I put dashed line represent this as a parabola, but the other half doesn't really exist. So parabola is only start from here. But the 1, 1 point doesn't include it, right? Because here, no equal sign. X cannot equals 1 on the square function. So that's why this point need to be deducted, and everything on the right hand side of this point on the parabola is solid, and then the arrow pointing to positive infinity. Okay? And then actually we can look at a better graph. My hand graph is really not good. Okay? So let's look at a book, the perfect graph. Okay, so this represent f of x equals -2x plus 1, right? Remember, this is -3, 7. This point, 1, -1, shallow circle, so it doesn't really include it in this line segment. And a single point, 1, 2, right? And then the part of the parabola, right? This point, 1, 1 point deducted from the parabola, and then this arrow pointing to positive infinity. Okay, so that is the good graph, well, accurate graph. My graph is also correct, just not that perfect. And then the next question asks us use the graph to find the range of the function f of x. So let's use the better graph, okay, to look at it. Find the range is, we're trying to collect all the y, right? On the graph, we can see all the blue color one, okay? So the lowest point is right here, right? But doesn't include it. So we're looking for the y coordinates. So the range, the lowest y, it should be 91, but not include 91, okay? And the highest point is what? Go to infinity, right? So the range is from 91 to positive infinity. And then the domain, remember, domain earlier we talked about is from -3 to positive infinity. All right. And then let's go back to the question. The last question asks, is function continuous on its domain? Obviously, it's not continuous, right? So there's 3 pieces. They're not continuous. It's break up, okay, from here, and then jump to this point, and then jump again, okay? So the graph is not continuous on its domain. And I believe this is the last slides of section 3.4.